again, another section where we're going to say this is a pretty important set right here. So I had to put the word important right up here again, important set of notes. Very important stuff here again. So get that down up there. Guys, we just got done talking about distributive property. We said distributive property is a way to write variable expressions. A way of writing variable expressions that are equivalent, one with parentheses, one without. So don't forget about that stuff as we move through this. So, guys, section 2.3 is called simplifying variable expressions right here. Our goal is going to be very important for us as we progress through the rest of the year is to combine like terms, all right? This is going to be something that's essential to the class, so you'll want to make sure you understand this. And we're going to use combining like terms to simplify variable expressions. Okay? All right, first of all, what is a variable expression? All right, up here I've got an example, and I've got one that's not an example. Guys, take a look at this example right here. It says variable expression. What makes this a variable expression according to the bottom right here? What's that say? Tim?
It has letters.
It has letters. So right up here I have 5x plus 4x plus 7. Remember, variables are nothing more than letters representing a number, some kind of an input. All right. All right. So what makes this not a variable expression on the right?
It doesn't have letters.
Doesn't have any letters in it. So you understand what a variable expression is and what a variable expression is not? You guys okay with that?
Yeah.
Okay. Well, let's take a look at this right here. Guys, this part that I'm going to go ahead and highlight here quickly. Let me do this. Part that I highlight here real quickly is going to be very important for you. So you might want to go ahead and highlight or put a star by this or something. But this box right here in your vocab is going to be very important today. So make sure you understand what's going on right there. All right, this is important stuff today. Okay, guys, variable expressions are going to have a lot of terms that we use in them, all right? We're going to have what we call, what are the terms of a variable expression? You're going to hear me talk about coefficients a lot this year. You need to understand what a constant term is. Also need to know what like terms are. So in this first example right here, guys, it says, in the example that I have right up here, 2x plus 3y plus 4y minus 7, it asks us to identify all of my what here, guys? It asks you to identify all the terms, doesn't it? Okay. Well, guys, I'll just tell you right here, for any terms right here, it's just part of the expression. So guys, if I would count here, forgetting the plus signs and the minus sign right here, how many different terms do you have in this expression? 1, 2, 3. Looks like how many terms are in this?
4.
How many blanks did I leave you for this? Okay. What's the first term look like it is here, guys? 2x. So I'm going to fill in 2x. All right. What's another term in that expression, guys and gals?
3x.
All right. I agree. 3x. How about another one?
4y.
4y. Now I want you to be very careful on the last one. Okay. Yeah. What'd you say there, Kyle?
-7.
Why are you saying -7 there?
I don't know. It's because the negative.
There's a negative sign right in front of it, okay? As I wrote 2x, 3x, and 4y, didn't put any signs in front of them, so we assumed they're what kind of a value? Positive, right? Okay, do I need to put plus signs down when something's positive? Okay, so right here, since that 7's got a minus in there, you hit it right on the head there, Kyle, and that's a nice job. Yeah, -7. Anything that's got a minus sign in there is considered what kind of a value? Well, it'd be considered negative, right? If I would have put 7 up there, that would have been +7, right? And is that what's written in the expression? What's written? -7's written, right? Okay. All right. Well, so we understand what the terms are. Basically, write everything down in the problem. Second thing then is this, any kind of a coefficient. They're going to say, what are the coefficients in this problem? Well, what's it say the definition of a coefficient is right here in the middle? Somebody want to read that for me? Number in front of a letter, okay? Well, how many letters are up there, gang?
3.
3 total letters, right? A couple of them occur each couple times, but what number's in front of this first variable x right here?
2.
So one coefficient is a 2.
2.
How about the coefficient on the 3x? What's that?
3.
And then we got a 4y up there. Do we know the coefficient for that? Just a 4. It's the number right in front of a letter, okay? So the 2 times x, how many x's do you have? Coefficient just tells you how many of a variable you have, okay? Then, we have what's called a constant term. A constant term is going to be a situation where you have a number, but that number is not right next to a letter. Is there anything in the same expression, 2x plus 3x plus 4y minus 7, that's constant or not right
7.
next to a letter?
7.
What kind of 7 again, Tim?
Negative 7.
Negative 7. Okay? And then the last part of this, guys, is to say like terms. All right? Now, the definition for like terms, in this part right here, in the like terms part, this part's going to be very, 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 important. This is a biggie, okay? Terms that contain the exact same variable. Any terms up here that contain the exact same variable?
2x and 3x.
2x and 3x. Okay. So guys, if I give you expressions, can you identify what a term is, first of all? Can you identify what coefficients are using this menu? How about constant terms? You understand that part?
Yep.
And then finally, like terms. You understand what a like term is?
Mm-hmm.
Now, you may have more than one pair of like terms. Here, the only terms that are alike are the 2x and the 3x. You might run into situations where you have multiple x's and multiple y's. You would group all the y's together, group all the x's together. So it's possible that you have multiple groups or more than one group of like terms. Okay, first page. Any questions at all, gang? Anybody? All right, second page then. This, again, very important stuff. Highlight it, star it, do what you need to. But this stuff is very, very important right here as well. Okay? We're going to start talking about this whole concept of what we want to do in this section. And our goal at the beginning was, how do you simplify variable expressions? Okay? Basically, a roadmap for you to follow right here. Ask yourself the first question. Can you do it? Ask yourself the second question. All right? Well, guys, anytime you simplify expressions right up here, the first rule says to do what? What's that first word in rule number 1 right here? What's it say? Distribute. And distributing allows us to rewrite an equivalent expression, or in other words, get rid of what? Any parentheses. Good. Okay, so let's just kind of revisit this here real quickly. Here's an example. I want to take 3 times x plus 9. I want to write an equivalent variable expression for this. You okay, John? Okay. Help me do that. I got to distribute 3 to this mess right here. What's the 3 times x going to get you there first, gang? 3x. Yeah, this is just like the assignment we graded this morning, right? And then I also got to take the positive 3 times the plus 9. So when I distribute, what's that 3x times positive 9? So an equivalent expression to this over here on the left with parentheses would be 3x plus 27. Okay? How about a volunteer to help me with the next one, just to review quickly in terms of what we're doing here if we have to distribute. What do you have here, guys? Negative 14x. Chelsea, that's good. Don't get caught on the second part, Chelsea. What are you going to have on the second part?
Plus 49.
Why is it plus 49, kiddo? Excellent. Negative times negative. You got it. Okay. So guys, our rules for simplifying variable expressions right up here. Our rules for simplifying variable expressions. What's the first rule to do? If there are any parentheses, what do we have to do? What's the word I highlighted here? Distribute. You got to get rid of parentheses first. Now, the part that's new for you today in section 2 is to go ahead and combine like terms. This is what's new right here. Now we know what like terms are. Going to be any terms with the same exact variable. We're going to try and put those together. Okay, so here's an example of combining like terms right here. This is what's new. Over here we have, first of all, a 3x plus a 12x. Do you first of all agree that 3x and 12x are terms that both have the letter x in it?
Yeah.
Okay. Well, if I had 3 x's and add 12x, it's just like saying if you had 3 $1 bills and 12 $1 bills, aren't they all the same thing?
Yeah.
Well, if you add them together, how much would you have totally? 15. This is saying the same thing. You got 3 x's and to it you're adding 12 x's. How many x's total when you add them up? 15x. Do you understand why what's on the left combines to what's on the right here then?
Yeah.
Another example over here. What kind of a 4y do you have here, gang? It's negative, isn't it?
Yeah.
And you're adding 7y. First of all, are the variables the same? Okay. So what's a negative 4y plus 7y going to combine to here? What's it say? 3y, right? So do you understand that what we're doing is we're taking these terms and combining them together to simplify? Negative 4y's plus 7y's would be 3y's right there. Okay? Alright, now before we can proceed in this right here, we got to have a really good understanding of what like terms are and what like terms are not. And this is a really good table. This is a really good reference table right here. Stuff on the left, examples of like terms. Can you combine like terms? The answer is what?
Yes.
Yes, you can. So just real quickly here, gang, help me out. 3x plus 7x on the left. What would that equal to combine them? What would it be there? 10x. Okay. Hey, I want to note something. Number 2, check this note out down here. Okay. It says note, x is the same as what, gang? 1x. And negative x is the same as negative 1x. So right here, guys, I have how many x right here? 1 plus how much more?
6.
What's that add up to first?
7.
7x, and then take 7x and subtract what? 9x. What's 7 minus 9, gang?
-2.
Negative 2 what then here? Very good. See, we can combine these. These are example of like terms. Like terms can be combined. Last one down here. Notice, I've got a variable, but the variable also has an exponent here, doesn't it? But the 8r squared and the 12r squared, same letter, same exponent, so you have the same variables. They're like terms. I can combine them. Help me out. What's the 8 minus the 12 going to get you? Positive 4 or negative 4? So I call this negative 4 what here, Chelsea? R to the second. Like terms can be combined. Therefore, I was able to go ahead and put equals behind them. Now over on the right, I've got some non-examples of like terms. What makes 5x minus 78 a situation where you can't combine anything?
Because the 7 doesn't have an x.
78 doesn't have an x, the 5 does, therefore, can I put them together?
No.
The answer is what?
No.
No. How about the next one? Why can't you put x plus 3y together?
Because the x and the 3y aren't the same.
The variables are different, right? Oh, so the next one you should be able to put together because they both
No.
have x's.
Nope.
What's tricky about this one?
Exponent.
There's an exponent with 1, but not an exponent with the...
Other.
So the exponents along with the variable, you would say, would have to still be the same thing, right?
Yeah.
Okay. You understand what like terms are on the left and on what like terms are not on the right here? Okay. Well, then let's go ahead and try a few examples here quickly. Combining like terms. Now keep in mind, guys, I'm going to scroll back to the top here. Always, always, always try to do what if possible? Distribute. Allow you to get rid of the parentheses here. That's kind of what that says there, all right? Distribute to get rid of parentheses. Is every problem going to have parentheses in it? Not all the time. So you always check to see if there's parentheses first. If not, then go ahead and combine like terms. So real quickly, this first example down below, it says, whoops. It said, whoops. Yeah, man. Yeah, man. Yeah, man. Okay. First one says 12x plus 8x. Are there any parentheses?
Nope.
Don't have to distribute. So the second question is, what are there any like terms in there then?
Yeah.
What's a like?
12x and the 8x.
I would say 12x and 8x are both like terms, so you're good to go. So can I simplify this further? What would you say it equals?
20x.
20x. 12 plus 8 is 20, so 20x. I agree. Okay. Take a look below at number 2. Any parentheses in number 2 here? Down the bottom? Okay. Anything alike?
Yeah.
What's alike?
3x and 9x.
Okay, I like to sometimes do this. Sometimes I like to say, okay, this 3x right here is like the 9x. But what kind of 9x is this again?
Negative.
Negative. Okay, you gotta be careful. There's a minus sign in front of one of the terms. You have to assume for sure, that that's negative. So how about positive 3x and negative 9x? What would that combine to?
Negative 6x.
negative 6x. I agree. 3 minus 9, negative 6x. Now the part in red is what I combined to get to negative 6x, right? Is there any part of the expression still left in there?
7.
What kind of 7, kiddo?
Positive.
So what am I going to write after the negative 6x to simplify this
Plus
expression?
7.
You'll want to put a plus 7. Very good. Okay. And again, this is just like example number 1 over here in the non-example. This is like non-example number 1, in other words. I can't put the negative 6x and 7 together because one part has a variable and one part does not. So can I simplify this any further?
No.
So I would say that this is its simplest form right here, negative 6x plus 7. Okay? What do you guys think about this so far?
Yeah.
Feel pretty good about it?
Yeah.
Next one. Number 3. 6x squared minus 9x plus 2x squared. Any like terms?
Yeah, 6x squared, and then 2x
Can
squared.
I argue that they're all alike or not?
No.
What's the problem here with the middle term?
Negative 9x.
Yeah, it doesn't have the same, has the same variable but not the same
Exponent.
exponent. Okay, so I'm going to combine, looks like to me the positive 6x squared and the positive 2x squared, right? Well, help me out, kiddos. 6x squared, 2x squared, both are positive. What's that simplify to?
8x squared.
So what's this going to look like in simplified form, everybody?
8x squared. And then negative 9.
Minus 9x. Okay. All right. Well, then number 4 is kind of the difficult one. If you can handle number 4, you can handle lots of stuff today. Okay. So you might want to put a star by number 4. Guys, in number 4 are there parentheses this time.
Yeah.
So going back to the top of your notes, take a look up there. The first part says if there's any parentheses, you have to deal with that first, right? Okay, in this case we have to. So let's rewrite this problem right here. Help me out and distribute. How about the 4 times the x right here? What is that? And then how about the 4 times the plus 6? Plus 24. Then I'm going to write the remainder of the problem behind that. But you get that the 4x plus 24 is the distribution from the 4 to that quantity x plus 6, right? Then behind that you still have a minus 2x and you have a plus 8, right? Okay. So this is kind of an interesting cat right here because in terms of our like terms right here, is there anything that's alike? What's alike first? Do you identify any set that's alike so far? What's one of them, Allie? 4x and what kind of 2x is that, kiddo?
Negative.
Okay. Now, check this out, guys. The parts that I didn't circle, look at them carefully. What are the 2 parts I didn't circle?
24 and 8.
24 and 8. Look at the front page of your notes again.
They're like two.
They are going to be alike because they're both
Positive.
they're both positive values. They're considered constant terms, aren't they?
Yeah.
All right. So in this case right here, it turns out instead of having just one constant term like we've had in the other examples 2 and 3, how many constant terms do you have here and here? Well, you got a plus 24 and plus 8, right?
Yeah.
You'll be able to combine those. So real quickly here, gang, what's the 4x and minus 2x going to combine to?
2x.
Okay. And then how about your plus 24 and plus 8? That's like adding how much?
Would be 32.
All in one shot, adding 32. So simplified form here is 2x plus what value?
Would be 2.
There you go. Okay. Does this make sense? Because this stuff is very important, critical for moving on this year.
Yeah.
Are you guys on board with me right now?
Yeah.
Any questions to this point? Give me a show of hands right now and say, yep, I think I'm feeling pretty good about it. About everybody, good. Okay. All right, well, real quickly, let's run through the last page here, and then we'll get you on your way to go get some Chromebooks today.
Hey, John, you sure you're okay?
I have a question.
Yeah.
Alright, I didn't turn in my paper, but I have it with me.
Take it to advisory with you, okay?
They'll still give it to me if I have the paper.
Yep. Yep. Okay, they will as long as you've got that paper. Yep.
Alright.
Yep. Okay. Hey, everybody listen up. I want you to try these 3 problems on your own real quickly, all right? Take a minute and do so, please. when you've got those three solutions to the on your own, check with a neighbor. See if you agree. If you disagree, talk about why you disagree.
Wait, what are we doing now?
The on your own's at the top of the third page, Jen.
Okay. 2x.
Kyle, where's that sheet of grades at? Is it on my desk?
Saving. I don't know how to do this.
Hang on, you're fine. It's okay. All right, in the essence of time, I want to run through this real quickly here. Just taking a look at this. What can I combine? Can I combine all of these in the first one? I can. They all have the x in there, right? So what's the 12 plus 7 going to get you first, guys? 19 and then 19 minus 8? What's 19 minus 8? John, chill out. I'm going over it, okay? Are you with me?
Yeah.
All right, hang in there. All right, 12 plus 7 is 19, we said, right? 19 minus the 8 is 11x, all right? Everybody understand why 11x right there? It's just 12 plus 7 minus 8. They all have the x in there, so I can put all three of them together there, right? Okay. Next one, 21x squared plus 17 minus 14x squared. What are my like terms there, Taryn?
Well, I have a question.
Yeah.
How do you know if it's minus 8 or negative?
Well, what kind of sign's right in front of the 8? Minus, right? So that's what it's got to be. You okay with that? Yeah? Okay. What can I combine in the second one then? Quickly, what can I combine in the second one? 21x squared and the...
14.
Okay, what kind of 14x squared, however?
Negative.
So what is 21 minus 14?
7.
So this is 7x squared. I'll cross those out because I combined them. Those are combined now. What part of the expression still remains from the original?
17.
So what are you going to put at the end? Plus 17, yep. Okay, last one then right here. I would take negative 3 times what?
We're almost at time.
Take negative 3 times what?
Okay.
2x.
No. Negative 3 times the parentheses set.
Oh.
Negative 3x, right?
Yeah.
And then the negative 3 times negative 7 would be plus
21.
21. Hold on, don't leave. Stay here. If you're walking through, go quietly, please. Okay. You guys agree I can combine negative 3x and 2x?
Just go to your advisor at this time. Go
Guys
to
agree?
your advisor.
Yes.
What's negative 3 plus 2? Isn't that negative 1x?
Yes.
Yeah.
All right, and then finally plus what on the end of it?
21.
Okay. Hey, that book page I gave you, when's that due? Wednesday. All right, bring these notes back with you tomorrow. We'll go ahead and finish that up. You guys have a good day, all right?